So first of all, we will discuss what do you mean by heaps. So whenever anyone asks you what is a heap, it is also a binary tree. You know what is binary tree? What is a binary tree? What is a binary tree? Root. So whenever we are talking about tree, so obviously a tree will have a root and its branches. That's true. But what about binary tree? Specific sort. How to arrange element as binary. See, actually, in case of a binary tree, okay, we have a root node, okay, and that root node will have its child nodes. Now, in this case, a node will have at most two child nodes. This is the difference between a tree and a binary tree. Suppose if I draw this, okay, this is my root node, and this is my child node, okay. So this is a tree. You can call it a tree, okay. And if I draw this is also a tree, okay. And if I draw this is also a tree, because here you have nodes, and one node is a root node and other nodes are child nodes. But which one is binary tree out of these three? First one is binary, yes. Why? This one is binary, absolutely correct. Why? It has two childs, exactly. Okay, so this is what we call binary tree. So a heap is also a binary tree, but here it has two major properties, two important properties. This is first property, that it is almost complete. Now see this point, all nodes are filled in except the last label may have some nodes missing towards the right. Now what do you mean by this? See this example. Now this is a heap. Here you have a root node, okay? It is a binary tree, so every node will have two child nodes. So this is label 1, this is label 2, okay? Now if you want to insert a new node, you will go to label 3. So this is label 3. Now here you can see, once you are at label 4, here, see, some nodes are missing towards right, okay? Our tree is up to here. These nodes are missing, okay? So that's why all nodes are filled in except the last label may have some nodes missing towards right. Why towards right? Because we start from left. Here we start from left. Now if a new node will come, where you will add that node? You will add it towards right. Okay, so this node will have two child nodes then. Now next node will be added here at this point and so on. So the first point is it is almost complete. Okay, we always start from left and we move towards right. And now see the second property. The tree fulfills the heap property. Now what is the heap property? What is the heap property? Binary tree. Okay, it is a binary tree. That's right. But what do you mean by heap property? What is the heap property? The heap property is the root node has minimum value, then its left subtree and right subtree. Okay, in case of heap. So as you move downwards, okay, so all nodes store values that are as large as the values stored in their descendants. Now if you see this example, the root node has minimum value, then the left subtree and right subtree, isn't it? 20 is smaller than 75 and 43. Okay, and now as you move downwards, you will find out that value increases. Now here you have 84. Okay, 84 is greater than 75 and 20. Great value, larger value. Now you see here you have 84, then 90, 57, 71. And then you have 93, 91 and 96. So these values are larger than these values, isn't it? See? Yes, okay. So this is the heap property, that all nodes store values that are at most as large as the values stored in their descendants. So as you move downwards, the values increases in case of heap. And you have to, what about the arrangement? Yes, the arrangement is like this, that if you are talking about min heap, okay, if you are talking about min heap, then the root value, okay, then the root value is smallest. And if we are talking about max heap, there are two types of heaps, min heap and max heap. And if we are talking about max heap, the root value is largest. Okay, the root value is largest. Okay, I'll show you an example. See, this is root, this is the smallest, 20. Okay, now see, this is one tree. Okay, here 20 is the smallest, root value is the smallest. Now you see this subtree. See this subtree. Here root value is 75. So it is the smallest, then 84 and 90. Isn't it? Yes, okay. Now see this subtree. Now here 43 is smaller than 57 and 71. Yes? Okay. And if you see this subtree, 84 is smaller than 96 and 91. And similarly, 90 is smaller than 93. So which type of heap this is? Which type of heap? Exactly, very good. So this is min heap. Now if we are talking about max heap, the root values will have larger value than its left subtree and right subtree. Okay. Now here we have how to insert a value in a heap, how to delete a value from a heap. This point is clear, or I should explain it? This is clear. Okay, so let's move to next slide. So this is how you can remove elements from a heap, how to insert a new element into a heap. Then we have priority queue. So can you tell me which type of data structure queue is? Queue is which type of data structure? Last in, first out, or first in, first out? It's a last in linked list. Not linked list. It's a first in, first out. Okay. So it's a first in, first out data structure. Now, here we are talking about priority queue. Okay. So the difference between priority queue and queue is? What's the difference? How to arrange data in a queue. See, the difference is, this is our queue. Okay. This is our queue. Now, as you know that queue is first in, first out data structure. Okay. So if I have A, B, C, D, E, F. Now they are inserted in this order, A, B, C, D, E, F. Now when you will remove these elements from queue, what will be the order? What will be the order when we will remove these elements from queue? You have inserted A first. Okay, first of all you have inserted A, then B, then C, then D, then E, and finally F. This is how you insert it. Now when you have to remove these elements, what will be the order? The same order, exactly, same order, because this is first in, first out data structure. Now when we are talking about priority queue, okay, when you will remove these elements, the order will not be like this. Okay, the order will not be like this. Why? Because we will assign priority to these elements. Okay, suppose I assign priority 1 to C. Okay, priority 1 to C. Then priority 2 to E. Okay, and 3, 4, 5, and 6. Now tell me what will be the order when we will remove these elements. What will be the order when we will remove these elements? The highest priority first. Okay, good. C, and after that E, then B, then A, then D, then F. Okay, so the elements are removed according to their priority. So this is the difference between priority queue and simple queue. Now when we are talking about tree, clear, good. Now you should see over here, this is a linked list. Okay, this is a linked list. Now, what is the difference between tree and linked list? Linked list is a data structure. Okay, and we have tree. Tree is a hierarchical data structure. Now, what's the difference between two? Okay, see, here we have node 1. No, there's a difference. There's a difference. Now you can see here we have node 1, node 2, and this is the link. Okay, means in case of linked list, you have nodes, and those nodes are connected to each other, isn't it? There's a link like this. This is a linked list. Okay, now see, this node is connected to only one node. And then second node is connected to third is connected to fourth, and so on, like this. Okay? So you can think of this as a parent node, and this parent node has one child node. Okay? Now, this is the parent node, and this is the child node, and so on. So every parent node has just one child node, isn't it? And they are connected in sequence. Yes. Now see the tree. What is the tree? We have a node, okay? We have a node, and this node can have more than one child nodes, isn't it? It can be 2, it can be 3. If we are not talking about binary tree, then the child nodes can be 1, 2, or 3, or 4, like this, isn't it? And then, okay? See, if binary, yes, if binary, then a node will have 2 child nodes, okay? And again, see, this will have 2 child nodes. And if it is not a binary tree, then it can have 3 child nodes as well. Okay. So now see the difference. This is a tree, this is a linked list. It is clear? Good. So this is the difference, basic difference between a linked list and a tree. Although both are data structures, but the difference is your linked list is a linear data structure and tree is a hierarchical data structure. So you can see this is a tree. Here it has 2 child nodes. Here it has just 1 child node. Okay. But in case of linked list, it will have only 1 node. So these are some of the concepts, basic concepts. You know that. Now, see this. This is an example of binary search tree. Now, can you tell me the difference between binary tree and binary search tree? What is the difference between binary tree and binary search tree? Divide it into 2 parts. How you will divide it into 2 parts? On what basis? And arrange the element depending on value, okay? Depending on value, you have to arrange. How? The big in left, big in left, and small in right. Okay, see this example. See this example. What do you think? Big element is towards left or right? Big is towards left. How? If you see this tree, okay, see this tree, 10 is big, isn't it? 10 is big, okay? And where is it? Is it towards left or right? In the left of root. See, big elements are placed towards right, okay? Big elements are placed towards right, and small elements are placed towards left, okay? Now, if you have to create a binary tree for these nodes, what you will do? You will start from left. Start from left. So first of all, you have 8. This is your root node, okay? Now 10. 10 is bigger than 8. It is greater than 8. So it will be placed towards, it will be placed towards right, yes. Okay, right of root, right. Now next is 3. So 3 is smaller than 8. It will be placed towards left. So this thing you have to remember, otherwise your tree will be wrong. Okay. Now next is 14. So 14 is greater than 8. It will move towards right. And again 14 is greater than 10. So it will move towards right. So here you have 14. 14 towards right. See, towards right. Yes, right of 10. Okay, there is no space, that's why I have created like this. Then you have 1. 1 is smaller than 8. Then 1 is smaller than 3. So towards left of 3. And so on. Okay, so remember the difference between binary tree, yes, is smaller than 8 and 3. So the difference between binary tree and binary search tree is that in case of binary search tree, you have to place big elements towards right and small elements towards left. But this condition does not apply for binary tree. So as you can see over here, these are the two properties of binary search tree. Okay, this is the property of binary search tree. And what is binary tree? It consists of 2 nodes, each of which has 2 child nodes. This is the binary tree. And this property holds only for binary search tree. It does not hold for binary tree. So this is the difference. Is it clear? Okay, good. Now tell me, if I want to traverse, what do you mean by traverse? What do you mean by traverse? Traverse means to travel, to move. Okay? If I want to move through a binary tree, what are the 3 ways? There are 3 ways to traverse a binary search tree. What are those three ways? Tree traversal. What are the three tree traversals? These are the three tree traversals. Okay. First is pre-order, then in order, and finally post order. So these are the like iterations. These are not iterations, no. These are traversals. These are traversals, means how you will move in a binary search tree. Okay, so pre-order, in order, and post order. Now in case of pre-order, what you will do? What you will do in pre-order? Left, root, and then right. See, left, root, and right is in order traversal. Okay. First of all, you will visit left subtree, then root node. Okay. Then root node, and then right subtree. This is in order traversal. What is in pre-order? Right, root, and left. No, no. See, in case of pre-order, first of all, you will visit root. Okay. First of all, you will visit root. Then you will visit left subtree and then right subtree. Okay. And what is there in post order traversal? What is there in post order traversal? First of all, left, then right, and then root. Okay. Left, right, and root. This is in post order traversal. So this thing you have to remember. This thing you have to remember. You have to memorize it. Okay. Otherwise, you can make mistake. There will be a mistake. So this is pre-order. Visit root, then left, then right. Okay. Root, then left, then right. This is pre-order. Then in order, left, root, and right. So we have left, root, and right. This is in order. And then we have post order, left, right, and root. So this is left, right, and root. Okay. So you want me to discuss an example or it's clear? Okay, no problem. Just go through this chapter, and if you have any problem, you can mail me anytime. Okay? Try to do lots of examples. Try to solve examples, because this thing needs practice, inshallah. Inshallah, because this thing needs practice and there's a lot of confusion. So if you will practice it a lot, then there will be no confusion at all. Just remember few points in your mind and it will be easier for you to do it. Okay? It's like a game. It's very easy and very interesting. It's like a game. Worried about code. Yes, for coding also, you have to practice. Okay? You need practice. Now, one more thing I want to discuss. There are two types of trees, balanced trees and unbalanced trees. So, can you tell me the difference between balanced tree and unbalanced tree? Okay, you will study Java in summer. That's good. That's very good. During your summer vacations, you should study this programming subject and try to write code and do programs as much as possible. Okay? Now tell me, what's the difference between balanced tree and unbalanced tree? Don't worry. Don't worry. If you will practice, inshallah, you will be a good programmer. Programming needs practice and nothing else. Okay? So don't think that you are weak in code. No. If you will practice, inshallah, you will be perfect in programming. Okay? In the beginning, it's difficult for everyone. But once you will practice a lot, everything will be easier for you. And you will find it very interesting. Inshallah, you will be a good programmer. Don't worry. If you will work hard, you will be a good programmer. Now tell me, what is the difference between balanced tree and unbalanced tree? See this diagram. See these diagrams. What's the difference? Okay, now I'll tell you the difference. In a balanced tree, all paths from the root to one of the leaf nodes have approximately the same length. This is the difference. Now what do you mean by this? Start from root. Okay? Start from root. This is root. And what are the leaf nodes? These are the leaf nodes. Isn't it? These are the leaf nodes. What do you mean by leaf node? What do you mean by leaf node? Yes, which has no children. Okay, a node which has no children is known as leaf node. Now find out the length from this root to this leaf node. What is the length? If I move, yes, good. This is 4. Okay. What about this? What is the length? Again 4. Okay. And here the length is 5. Isn't it? The length is 5. Now this is level 1, level 2, level 3, level 4 and level 5. Now the leaf nodes which are at level 4, they have same length. Similarly, the leaf nodes which are at level 5 have same length. As you can see in this definition, all paths from the root to one of the leaf nodes have approximately same length. So this is a balanced tree. This is a balanced tree. Now see this example. This is the root node and these are the leaf nodes. This one and this one. Okay. Now here the length is 2. The length is 2, yes. And here the length is 5. So this is unbalanced tree. This is unbalanced tree. Different lengths. Now, what do you mean by maps? Maps. Relation. Function. Okay. So it is. Okay. So here we have map. Okay. And it shows association. Okay. Between keys and values. Map is basically an association between keys and values. Yes. Okay. So here you can see we have 4 keys and 3 values, and this is a line, and this line is basically an association. Association. So this is map. Now there are 2 ways by which you can represent map: hash map and tree map. 2 ways. Okay. These are some codes which will help you to represent maps by using hash map or tree map. To enter new entry, what we have done, we have just removed previous entry and we have associated it with new one. So here, now the association is with yellow. And similarly, if you want to change the entry, just change it by using put and then changing the value. And if you want to remove any entry, you have to use remove keyword. So these are the ways by which you can represent map. If you have any question, you may ask. Any other problem in any topic? Everything is clear? Okay. Anytime you can mail me. Okay, if you have any problem, you can mail me anytime. Inshallah. All the very best for your exam. I hope that you will do your best and you will start preparing it from now onwards, and inshallah everything will be fine. If you will study hard, you will get good marks. See you. Take care. Assalamu alaikum.